this video, I'm going to describe the supporting ongoing changes in thinking practice in the context of the Megadrought and the Colorado River Basin data puzzle. So the goal of this practice is for students to test their current understandings, their current predictions for the investigative question against an authentic data set. And so for this practice, before sending students away to analyze and interpret this authentic data set, it's super important to first talk about the graphs in small groups and then as a whole class. Really important that students are familiar with the graphs, what the axes mean sometimes, and in this case, having students identify extremes, highs and lows, and talking about what those means before sending students away to identify and explain patterns they see in the data sets. So for this, students will work individually or in pairs to analyze the data sets, up to you. And we would encourage you, after having these discussions about the graphs and the data sets, to utilize data analysis strategies that maybe are already embedded in your classroom instruction. One that teachers that have used these data puzzle resources are particularly fond of is the whiz-wim strategy, what I see, what it means. And so if you have other strategies that are helpful for students in analyzing data sets, feel free to utilize them here. So diving in, students have just made an initial prediction for the investigative question, what is causing the Megadrought in the Colorado River Basin? And so now it's time to test their prediction by analyzing temperature and precipitation data set from the Colorado River Basin. And so here on the right is a Colorado River Basin temperature data set from 1900 to 2021. The y-axis is the average temperature from 48 to 55 degrees Fahrenheit. And on the x-axis is time from 1900 to 2021 beyond. And so you were asking students to maybe you point out some of the title and the axes. Maybe you have students do that, and then ask students to identify which year had the highest average temperature. Ask students to then identify which year there was the lowest average temperature. And so by doing that, you're keying in on students into certain aspects of the graph. High temperature being more recent, cooler or lower temperatures being over 100 years ago. So you're kind of prepping students to identify that increasing trend that we see in temperature over the last 120 plus years. You'll do the same with the precipitation data set. We're looking at the Colorado River Basin precipitation, a data set from 1900 to 2021, so that same time period, average precipitation in inches on the y-axis, the year going from 1900 to the present on the x-axis, and then asking students again to identify highs and lows in precipitation. You can see the low is in 2020 here, the high back around 1940. So we might see a slight decline in precipitation over time, but fairly consistent throughout, although we see many more really dry, low precipitation times since the year 2000. So something to key in on there. So after talking about these graphs, it's time to send students away to analyze and interpret these graphs on their own by answering questions 4 through 6 on their student worksheet. So they're identifying patterns, looking to explain these patterns, and then put that back into the context of their prediction for the investigative question, what is causing the Megadrought in the Colorado River Basin? Is their prediction confirmed by the data set, refuted by the data set? Give them an opportunity to revise their prediction for the investigative question. I want to take us now to the student worksheet to look at this supporting ongoing changes in thinking practice and see what it looks like there. So on the student worksheet pictured here, we can see that you've got both of these data sets, temperature and precipitation for the Colorado River Basin from 1900 to 2021. So students can refer to this page when they're discussing the data sets, being familiar. Then we ask students to identify those highs and lows over two distinct time periods, the time period of 1900 to 1999. And then for the time period of 2000 to 2021, this is the time period that is defined as a megadrought period. And so we're looking for how have the temperatures and precipitation, these average temperatures and precipitation, changed between these two time periods to figure out what's causing a megadrought over this time period. Having students identify patterns in the data, explain those patterns, and then revisit their prediction and revise it based on the data set. What students won't have when they look at these graphs up here, they won't have the average temperature from 1900 to 1999, the average temperature from 2000 to 2021, the average precipitation from 1900 to 1999, and again, the average precipitation for 2000 to 2020. So we would encourage you, we've got a spreadsheet linked with all of the data, temperature and precipitation linked in. We'd encourage you to calculate those averages together as a whole class. And so to do that, we'll calculate the average temperature and precipitation for the 1900 to 1999 time period here. And so to do that, we'll click on this cell next to average temperature and type in the code equals average, parentheses mark, and then just go over to temperature here, the date 1900, and it'll highlight all of the cells between 1900 and 1999. Press enter, and what we have is an average temperature for 1900 to 1999 right there. We'll do the same for precipitation over that time period, and then do the same thing for the 2020 to 2021 time period, and have students record those averages here. Once students have revised their prediction for the investigative question, it's time to move on to the final practice, constructing evidence-based explanations, where they take everything that they've learned from the interactive reading to this data analysis task and construct an explanatory model for the unit driving question.